All right, so here we are in question 1 of this paper. On the axis, sketch this graph here, stating the intercepts with the axes. Well, the first thing to notice is that this is going to be a cubic graph, and it will also be a negative cubic, right? Because if you were to expand this out, you're going to get positive 2x cubed, and then the negative here means that's going to be a negative cubic, and a negative is a cubic that looks like that, right? It slopes downwards. So that's the first point to make here. Next, what would be helpful? Well, we want to find where it intercepts the axes. Okay, so we want to find the x-intercepts and the y-intercepts. Well, where does a graph intersect the x-axis? It intersects the x-axis everywhere where the y-coordinate is 0, right? So we're going to say x-intercepts when y is equal to 0, which means basically we're finding the roots of this polynomial, right, like that. And of course, the negative of fifth doesn't matter, right? So we can get rid of that. So when is this going to be equal to 0? Well, it's either going to be equal to 0 when x is plus 2 is equal to 0, or 2x minus 1 is equal to 0, or x plus 5 is equal to 0, right? And so that's going to give us solutions either x is equal to negative 2, or x is equal to a half, or x is equal to negative 5, right? So those are going to be the roots or the x-intercepts of our graph. So I'm just going to indicate those on. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the roots are going to be at negative 5, negative 2, and over here at a half. Okay, so I'll put those on in red as well. So we've got to go through there, got to go through there, got to go through there. And then we want to find the y-intercept. Well, where does a graph cross the y-axis? It cuts the y-axis when x is equal to 0. So again, I'm going to write that down. So the y-intercept is when x is equal to 0. So I'm going to substitute x is equal to 0 into my polynomial. I'll get y is equal to negative a fifth, 0 plus 2, which is 2, 2 times by 0 minus 1, which is negative 1, and 0 plus 5, which is 5. Okay, and of course, a fifth times by 5 is going to cancel out to give 1. So we got 2 times by negative 1 is negative 2, and then that's negative. So it's going to be positive 2. So this answer here is a positive 2. So let's indicate that on the graph. 1, 2, right, positive 2 there. And of course, what I said earlier is that this is a cubic which is going to be sloping down. So we need to join these points together. So this is going to look a little bit bad, guys, but just bear with me. So it's going to slope down like that. Okay, it's going to come up through the x-intercept like that. Okay, like that. And it will come back down through 2, and then through that root there of a half. Okay, and that should basically be the graph that we're asked to show. Now, please could you notice, by the way, that I didn't make the y-intercept here to the same thing as the maximum point, right? Now, very often that is a mistake that students will make, and it can cause you to make errors in other questions. So the maximum point isn't necessarily the same as where the graph cuts the axis. That's something to bear in mind. Okay, part B. Hence, we want to solve the inequality where the polynomial is greater than or equal to 0. Okay, so we look at our graph and we say, where is it greater than 0? In other words, where is the y-coordinate greater than 0? Well, the y-coordinate is greater than 0 here and here, right? So let's just highlight that part of our graph. So we are interested in this part of the graph and that part of the graph. Well, what x values give us that part of the graph? Well, everything to the left of negative 5 and everything between negative 2 and a half, right? So the inequality is satisfied when x is less than or equal to negative 5 and when x is between negative 2 and positive a half. Okay, that will be the solution to that inequality there. And the way we do it is by looking at the graph. Okay, so this is question 2, which is a polynomial factor theorem, remainder theorem style of question. We've got a polynomial p such that p of x is equal to this thing here, and we want to find p of x in the form 2x minus 5 times by q of x plus r, where q of x is a polynomial and r is a constant. Now, the way of asking this question is somewhat unusual. It differs from the previous years in terms of the way it's been asked. But I think all it really is just a rearrangement of the thing that you're used to. So I'm going to try to explain. Imagine that we've got a polynomial, p of x, and what we do is we divide that polynomial by 2x minus 5. Okay, so we do that using the ordinary polynomial division. Then when we do that, what we get is we get another polynomial. So in this case, I'm going to call that q of x, right? So we get another polynomial q of x, and then sometimes we get a remainder left over. Now, what is that remainder? That remainder is the bit that still needs to be divided by 2x minus 5. Okay, so if you wanted an analogy, right, imagine that we did 10 divided by 3. Okay, now, if we do 10 divided by 3, the closest multiple of 3 is 9, and 9 divided by 3 is 3. But then we've got a remainder of 1, isn't it? And that 1 still needs to be divided by 3. So we write 3 plus a third, or more commonly, 3 and a third. Okay, so it's very similar to that, because what we're saying is we've got a polynomial, we divide it by 2x minus 5. Okay, we get this polynomial here, but we've got a remainder, and that remainder still needs to be divided by the 2x minus 5. Okay, now, if we were to take that line and rearrange it such that we multiply both the left and the right by 2x minus 5, what we would get is this. We would get p of x is equal to 2x minus 5 times by q of x plus r. Right? Because if you think about it, this guy, if I multiply it by 2x minus 5, I just get the remainder r there. Now, that is this thing here. Okay, so in other words, how do you find q of x? Well, q of x you get through your ordinary polynomial division. And what is r? R is going to be the remainder that is left over. Okay, so we're just going to do polynomial division. So we've got to get the polynomial 6x cubed minus 35x squared plus 34x plus 45. And we've got to divide that whole thing by 2x minus 5. All right? So we're going to do that full division there. All right? Now, how do we do that? Firstly, we take the leading term, 6x cubed, and we divide it by 2x. If we do that, what we will get is 3x squared. So I'll write that here, 3x squared. We then take that 3x squared and we multiply it by this whole divisor. Okay, so if we do that, what we will get is we will get 6x cubed, because 3x squared times by 2x is 6x cubed, minus 15x squared. Okay, so that's that first step. Now, once we've done that, we are going to subtract this bottom line from the top. Okay, so 6x cubed minus 6x cubed is 0. Now we've got to be careful. We've got negative 35x squared minus 15x squared. So minus minus is plus 15x squared. So negative 35 plus 15 is negative 20. So this guy here is going to be negative 20x squared. And we've still got the 34x plus 45 left over. Okay, so now negative 20x squared is our new leading term. We're going to divide it by 2x. If we do that, we're going to get negative 10x. Okay, and then we take the negative 10x and we multiply it through by this divisor. So negative 10x times by 2x is negative 20x squared. Negative 10x times by negative 5 is positive 50x. And again, we're going to have to subtract the one from the other. Okay, so negative 20x squared minus 20x squared is 0. 34x minus 50x is negative 16x. And we're left here with 45. Okay, we're almost at the end. The negative 16x is our new leading term. We're going to divide it by the 2x. And if we do that, we're going to get negative 8 there. Okay, and we take the negative 8, we multiply it through by 2x minus 5. which would give us negative 16x plus 40. And so then we are going to subtract that. Negative 16x minus 16x is 0. 45 minus 40 is 5. So in other words, what we've got, if we divide our polynomial by 2x minus 5, we get this thing here, 3x squared minus 10x minus 8, with a remainder of 5. Okay, so I'm going to write that down. End result is that p of x is equal to 2x minus 5 times by, what was it? 3x squared minus 10x minus 8. 3x squared minus 10x minus 8. And then with a remainder of 5, right? So this guy is our q of x. This guy is our remainder. Okay, let's go on to part B then. Okay, part B and C. Hence, we want to write the expression p of x minus 5 as a product of linear factors. Well, hang on. If we've got p of x is this thing, then all we need to do is subtract 5 from both sides, and we'll get p of x minus 5 is just equal to 2x minus 5, 3x squared, minus 10x, minus 8, right? So that's that. But if we just read the question very carefully, it says write it down as a product of linear factors, right? Now, this guy here is a quadratic factor, so we're going to need to factorize it once more in order to make it into linear factors. Okay, so we've got 2x minus 5. All right, now then, we're going to have to factorize this. Now, we'll practice it for the guys who are going to have to sit the non-calculator paper. We're looking for two numbers, or two things that multiply together to give 3x squared. Well, there's only one way to get that. You're going to get 3x, and you're going to get x. And then what we want is we want two numbers that are going to multiply together to give negative 8. Right, so one's going to be positive, one's going to be negative. We know that for sure. And it's got to combine in such a way that we get negative 10x. Well, if I was to put a negative 4 here, and I was to put a positive 2 here, that's going to work out. Because positive 2 times by negative 4 is negative 8. And then 3x times by negative 4 is negative 12x. And then this is going to be plus 2x. So negative 12x plus 2x is negative 10x. Okay, so this guy here is p of x minus 5 written as the product of linear factors, right? So we've just done part B. Okay, so part B done. Now, what about part C? Hence, we want to write down the solutions of the equation p of x is equal to 5. Well, let's think about that. If p of x is equal to 5, then what's going to happen? Over here, we're going to get 5 minus 5, aren't we? Which is 0. So we're going to end up with 0 is equal to 2x minus 5 times by 3x plus 2 times by x minus 4. In other words, basically what we've got to do is we've got to find the roots of this particular expression here. So how's that going to work? Well, this thing will be equal to 0 only when that's equal to 0, or that's equal to 0, or that's equal to 0. So if 2x minus 5 is equal to 0, x must be equal to 5.2. If 3x plus 2 is equal to 0, that will be x is negative 2 upon 3. And if x minus 4 is equal to 0, x must be equal to 4. Okay, so that will be our answer for part C, writing down the solutions of that equation. Okay. Now, just one final thought on that, guys. It looks like it's a bit of an unusual way of asking that question. And so it may freak some of you out, but actually just a little bit of extra working, hopefully you'll see, actually it's not too dissimilar from the questions you've done on other papers. Okay. All right, this is question 3, which is a logarithm style of question. We want to write 1 plus log x squared minus 1 minus 2 log x minus 1, where x is greater than 1, as a single logarithm to base 10, and give our answer in its simplest form. Now, at this point, it's always helpful to review the 3 basic log laws, which is if I've got log a plus log b, that's equal to log a times by b. If I've got log a minus log b, that's equal to log a divided by b. And if I've got log a to the power of p, then that is equal to p times by log a. In other words, I take the power and I can bring it down to the front. Now, I would add two things that are important for this particular question. One of them is this. LG, when you see that, log, that is a shorthand for log base 10, right? So that's log base 10 there. So when it says write it as a single logarithm to base 10, it means write it as log, which is what we've got in the question. The other thing I think which is very helpful is that if we've got log base a, that is equal to 1, right? So in this particular case, if we've got log 10, we know that that's equal to 1. Why? Because log is log base 10, so log base 10, 10 is equal to 1. Okay, so I think these things are also helpful in order to answer this question. Now, why is that? Well, firstly, we can take that 1 and we can replace it with log 10. So that's what I'm going to do. So I'm going to say here, this is log 10 plus log x squared minus 1. And now I've got this thing here, right? I've got the 2 log x minus 1. So before I can use rule 2, right, log a minus log b, firstly, I've got to deal with that coefficient there, that guy there. And the best way to do that is to use the third rule and to bring it up as a power of x minus 1. So that's exactly what I'm going to do, okay? So I'm going to do minus log x minus 1 all squared. Okay, all right then. Well, now that that's the case, I can actually begin to use my log rules, right? Because here I've got one log plus another log. So this is like log A plus log B. So that's going to be equal to log A times by B. And I've got another one here, which is a log minus a log, right? So log A minus log B. So that'll be equal to log A over B. So let me just do those in two steps, I think. So I will do these guys here first, okay? So this will be equal to log 10 plus log, big bracket, x squared minus 1 over x minus 1 all squared, right? Can you see that? Because what I've got is I've got log A minus log B is equal to log A over B, okay? And then I've got here the addition rule. So I've got log A plus log B. So I can write that as log A times by B. So this is going to be log, big bracket, 10 times by x squared minus 1 over x minus 1 all squared, like that. Now, for some of you, you may leave it like that, but we can simplify it. And the way we can simplify it is by factorizing this expression here. So I am going to write x squared minus 1 as x plus 1 times by x minus 1. I'm going to write it as the difference of two squares over x minus 1 squared. Now, why have I done that? Well, because I can now divide top and bottom by x minus 1, right? So that is going to cancel, and that's going to cancel. So what I'm left with is log base 10 of 10 bracket x plus 1 over x minus 1. And if you can see that, I have written this entire thing as a single logarithm to base 10, and it is in its simplest form, right? So I followed everything that I am required to do. Okay, then the second part of this log question, we want to solve this particular equation here, giving our answers in the form a plus b root c, where a, b, and c are constants. Okay, now what's the first thing you notice about this? We've got logarithms with two different bases. Here we've got a base 5, and here we've got a base x plus 1. So whenever this is the case, we know that we need to use the change of base rule. So let me write down that rule for you. If I've got log base a of something, let's call it x, and what I want to do is I want to change it to log base b of that same thing, then that means that I need to divide through by log base b of the old base, right? So if I want to change base a to base b, I need to divide through by log base b of that old base there, right? That thing there. Now, if you want a way of remembering that, basically on the right-hand side, the bases need to be the same, right? So on the top and bottom, the bases here are base b. Now, in this case, the easiest thing to change here, I think, is this guy. the log base x plus 1, 5. So I'm just going to apply that rule to this. So here we've got log base x plus 1, 5. And I'm going to change it to being base 5, right? So that it matches up with this guy. So if I do that, I'm going to get log base 5, 5 over log base 5 of the old base. And the old base was x plus 1. Okay, and log base 5, 5 is just equal to 1. So this thing is actually 1 over log base 5 x plus 1. Okay, so now that we've done that, I can take this equation and I can replace the log base x plus 1, 5 with this thing here. So that's what I'm going to do. So let's rewrite this. So I've got 4 log base 5 x plus 1. Let me write that down. 4 log base 5 of x plus 1 is equal to, what was it? I think it was 9. Yeah, 9 times by this whole thing, right? 1 over log base 5 of x plus 1. All right. Now, in this particular case, I think it's best to use a substitution because you can see that we've got this log base 5x plus 1 repeated twice. So even though it's not strictly speaking necessary, I think it's a good idea. So I'm going to say let u equal log base 5 of x plus 1. And that means that if I do that, I can write this as 4u is equal to 9 divided by u. And then with a little bit of rearranging, that's the same thing as u squared is equal to 9 divided by 4. And then if I square root both sides, I will get u is equal to plus or minus 3 upon 2, right? Because I square root 9, I get 3, square root 4, I get 2. And I need to remember I've got plus or minus. Now, wait a second, we remembered that u is log base 5 x plus 1, right? So actually, log base 5 of x plus 1 is either equal to 3 upon 2, or log base 5 x plus 1 is equal to negative 3 upon 2. So we need to do both of these. So first, let's rearrange. Our base is 5. Base is 5 there. And the power is 3 upon 2, and it'll be equal to x plus 1. So in other words, x plus 1 is equal to 5 to the power of 3 upon 2. Okay, and we can do the same thing with the other side, right? X plus 1 will be equal to 5 to the power of minus 3 upon 2. Okay, well, what are the indices rules? This guy here means, the denominator means root, so this is the square root of 5, and then all to the power of 3. So let's write that. This is the square root of 5, all to the power of 3. And what about on this side here? Well, same thing, but we've got the negative power. So the negative power means we've got 1 divided by that. So this is going to be 1 divided by the square root of 5 to the power of 3. Okay, now, root 5 times by root 5 times by root 5. What will that be? Well, root 5 times by root 5 is just 5. So this guy here is 5 root 3. Okay, and so therefore x will be equal to, if we subtract 1 from both sides, negative 1 plus 5 root 3. Okay, so that's going to be one of our answers there. Okay, not 5 root 3, beg your pardon, 5 root 5. I misread my own handwriting. How bad is that? Sorry about that. And what about this guy? Well, on this side, again, we could say on the bottom we've got 5 root 5. Okay, but we're going to need to rationalize this because we don't like having surds on the denominator. So if I multiply top and bottom by root 5, then I'm going to get root 5 on the top. And then on the bottom, root 5 times by root 5 is 5. Right, so root 5 times by root 5 is 5. And I've got to times it by another 5 will give me 25. So I'll get 25 there. And again, I need to subtract 1 on both sides. So x will be equal to negative 1 plus 1 upon 25, the square root of 5. Okay, so there's quite a bit of work there really to get those two answers. You know, it's a hidden quadratic. You've got to do the change of base. There's some surd work at the end. So it's not really an easy question. There's plenty of space to go wrong. But it's also kind of a good question for you to practice on to make sure that all of those components of your algebra are nice and tight. Okay, so I hope that that's helpful for you. Right then, question 4 is a binomial expansion style of question. The first three terms in ascending powers of x, so it means the powers of x are getting bigger and bigger. In the expansion of 3 plus px to the power n are this whole thing here, where n, p, and q are constants. We want to find the values of n, p, and q. All right, well, let's just crack on with doing the expansion, basically. So if we've got 3 plus px to the power of n. Now, the way I like to do this is I like to say, okay, our powers of 3 here are going to start from n and they're going to decrease. So we're going to power n, then n minus 1, n minus 2, and so on. And the powers of px are going to increase. So it's going to go from 0 to 1, 2, 3, 4, 5. So I'm just going to write that down nice and clearly. So we're going to get 3 to the power n, 3 to the power n minus 1, and 3 to the power of n minus 2. And then we're going to get px to the power of 0, and px to the power of 1, and here px to the power of 2. And of course, we've got, dot, 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 dot. And the other thing we've got is we've got coefficients, right? Now, coefficients are given by combinations, NCR. So we're going to start here with NC0, NC1, NC2, right? And all these things add up. Now, after you've done that, it's always a good idea just to check, right? Powers of 3 go n minus 1, n minus 2. That's good. Powers of p of x go up, so 0, 1, 2. And then the coefficients, so we go nc0, nc1, nc2. That's all correct, right? Now, if you follow the way that I do it, instead of just trying to write out each term like that, and then like that, and then like that, I think you're probably less likely to make a mistake, right? Because it's so easy, you make that a 2 or something by accident, or you forget that that's like -2 and make it -1, and then everything else goes wrong. So I think if you keep the order, generally speaking, you're less likely to go wrong. All right, let's simplify this. NC0, well, anything C0 is 1. 3 to the power n is just 3 to the power n. Then px to the power of 0 is 1, because anything to the power of 0 is 1. Next, nc1 is just n, because like 5c1 is 5, 6c6 is 6, and so on. 3 to the power n minus 1. And then px to the power 1 is just p times by x. And then the last term, well, nc2, we don't really know yet how to calculate it, so I'll just leave it as nc2. 3n minus 2. And then px all squared is going to be p squared x squared plus dot, 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 dot. Okay, so now basically what we've got to do is just got to compare, don't we? Right, so this term here, which is 3n, 3 to the power n, beg your pardon, has got to be equal to 243. Okay, so by comparison, 3 to the n must be equal to 243. And that's going to mean that n is going to be equal to 5. All right, so for the guys of you who can use calculators in your exams, which is this coming exam, then you can do that. For those of you who are not sure, right, 3 squared is 9. For those of you in future papers you can't use a calculator, 3 to the power 3 is going to be equal to 81. And, oh, sorry, not 3 to the power 3, 3 to the power 4, right, because it's 3 squared squared is what I meant to say. And then if you multiply up by another 3, right, 81 will become 243. All right, so if you think about that, 81 times by 3, so 80 times by 3 is 240, and then 1 times by 3 is 3, so 243. Okay, so even if you haven't got a calculator, it should be just about doable. Okay, let's get rid of that. Okay, so then we compare the next thing. So the next thing is to say that n times by 3 to the power n minus 1 times by p, that whole thing, must be the same as 810. So let me just kind of highlight that so it's nice and clear. The coefficient of x, which is that, must be the same as this coefficient of x, which was 810. Okay, that thing there. So if I was to write that down, we've got n times by 3 to the power n minus 1 times by p is equal to 810. Well, we know that n is 5, right? So we've got 5 times by 3 to the power of 5 minus 1, which is 4, times by p is equal to 810. And 3 to the power of 4 is 81, right? Because it's 3 squared squared. So we've got 5 times by 81 times by p is equal to 810. And 810 divided by 81 is going to be 10. So 5p is equal to 10. And that's going to mean that p is going to be equal to 2. Okay, so that's that. Okay, then we got the last term here, this guy, right? So I'll highlight it in red. That coefficient of x squared, that whole thing there, has got to be equal to q, right? The coefficient of x squared there. So let's write that down. So I'll go over here. NC2 times by 3 to the power of n minus 2 times by p squared must be equal to q. Well, now we just got to substitute in our values, right? So our n was 5. So this is 5c2. And we're going to get 3 to the power of 5 minus 2. So that's 3 to the power of 3. And p was 2, so we're going to get 2 squared. That's going to be equal to q. All right. Well, again, let's try to do this without a calculator. What's 5c2? 5c2 is going to be 5 factorial over 2 factorial, 5 minus 2 factorial, right? So that's a formula that's in the front of your exam paper. We've got 3 to the power 3, which is 27. And we've got 2 to the power 2, which is 4. And that's all equal to q. Okay, if I've got 5 factorial, that's the same as 5 times by 4 times by 3 times by 2 times by 1. And 3 factorial is 3 times by 2 times by 1. So if I was to cancel off, on the top, I'm going to be left with 5 times by 4. So I've got 5 times by 4 here. 2 factorial is just 2 times by 27 times by 4 is equal to q. And I think we can make our life a little bit easier by dividing top and bottom here by 2. So if I do that, I get 2 there. Okay, so then what are we going to get? We're going to get 27 times by 4, and then times by 10, right? Because 5 times by 2 is 10. So how do I do 27 times by 4? I double it, which gives me 54. I double it again, which gives me 108. And 108 times by 10 is going to give me 1080. Okay, so Q should be equal to 1080. All right, and that will be our final answer. All right, part B of our binomial expansion question. We want to find the term independent of y in the expansion of this, giving our answer in exact form. Okay, what's this expression independent of y means? It means that there's no y term. So if I was to write out the following thing, 4y squared plus 5 divided by y plus 7 minus 3y, right? This term's got a y, that term's got a y, this term's got a y, this term does not have a y. So in this case, the 7 is the term which is independent of y, right? It doesn't have it. Okay, now how can we find that in this expansion? Let's think about how we expand things binomially. So we've got 2y here plus negative 1 upon 3y squared, right? So I've deliberately written it like that, as instead of being minus, I've written it as plus a negative, all to the power 6. Well, if we were to expand this term, basically what's going to happen is we're going to get a 2y to some power. So let me write that down. We're going to get 2y to some unknown power. And then we're going to get this term here, the negative 1 upon 3y squared, negative 1 upon 3y squared to another power. Okay, and then lastly, what we're going to get is we're going to get a coefficient, and that coefficient will be 6c, some value here, right? So basically, every single term is going to look something like this. We just don't know what are the numbers that go here, here, or here. However, we do know that these two powers have got to add up to give 6, right? So this could be 0 and 6, or 1 and 5, or 2 and 4, or 3 and 3, and so on. But we want to choose them in such a way that the y terms are going to cancel out. So how could we do that? Well, if I chose this guy here to be a 4, and this guy here to be a 2, then what's going to happen is this term's going to become y to the power of 4, and on the bottom, we're going to get y squared squared, which will also be y to the power of 4. And so all the y's will cancel each other out, which is what we want. Okay. And then what about this number here? Well, this number here actually can be either that power or that power. It really doesn't matter. So I'll just choose 2. Okay. You could choose 4. That would be absolutely fine. So now what we've got to do is just got to really simplify this. And let's go through the steps. So 6c2 is the same thing as 6 factorial over 4 factorial 2 factorial, right? The formula's in the front of the book. 2y to the power of 4. So we're going to get 2 to the power of 4, which is 16, and y to the power of 4. And then we're going to get negative 1 upon 3y squared, all squared. Now, if we do that, Negative times by negative is a positive. So on the bottom here, we're going to get 1 upon 3 squared, which is 9, y squared squared, which is y to the power 4. And as I said, the y to the power 4 is going to cancel with the y to the power 4. Okay, so now all we've got to do is just got to simplify as much as possible. Well, firstly, 6 factorial divided by 4 factorial. Right, on the top, we've got 6 times 5 times by 4 times by 3 times by 2 times by 1. If we divide it by 4 times 3 times 2 by 1, we're going to be left with just 6 times by 5. And then on the bottom, 2 factorial is just 2 times by 16, and then divided by 9. Well, we can definitely cancel, can't we, right? We divide top and bottom by 2, so that disappears, and that 16 becomes an 8. We can divide top and bottom by 3, so that 6 will become a 2, and that 9 will become a 3. So on the top, it looks like what we've got is 2 times by 5 times by 8. And on the bottom, it looks like what we've got is we've got 3. Okay, well, what's 2 times 5 is 10. What's 10 times 8? 80. So we're going to get 80 upon 3, right? We've left our answer as requested in exact form. Okay, question 5, which is a trigonometric graph style of question. The diagram shows the graph of a cos bx plus c between negative 360 and 360, where a, b, and c are constants. We want to find the values of a, b, and c. Now, essentially, in these questions, you just need to understand what a, b, and c actually refer to. So let's kind of go through that in order. I'm going to start with C. Okay, what does C refer to? It is the shift in the y direction, which tells you the position of the center line. Okay, so there's the center line of the graph. So if I was to draw that on here, this guy is the horizontal center line of our cosine graph. Can you see that? Because the graph oscillates above and below that line. So where is that? That is the line through negative 4. So in this case, C must be equal to negative 4, right? So we can just write that down, right? C is equal to negative 4. All right. Now, what about B? B is the one that often causes people the most trouble, the most grief. And a lot of my students will tell me that B is the period. That is not correct. It is related to the period, but it is not the period. B refers to the number of waves in 360 degrees, or if you're in radians, in 2 pi, right? So it's the number of waves in 360 degrees. So let's just try to think about this. How many waves have we got in 360 degrees? Well, from this graph, it's a tiny bit hard to tell, isn't it, right? Because, we can go down here. That looks like a quarter of a wave. And then that's half a wave. And then we go up to here. And that basically looks like 3/4, doesn't it? So we're going to say, okay, B is equal to 3/4. Because we've got 3/4 of a wave in 360 degrees. But let's try to be a little bit more rigorous than that. Okay. Let's say to ourselves, okay, if we've got, let's say B was 2, right? So B was 2. That means we have 2 waves in 360. How big would each wave be? Well, it would be 360 divided by 2. Correct? Because if I've got 2 waves in 360 degrees, then each wave must be 360 degrees divided by 2, must be 180 degrees. In the same way, if B was 3, which means that there would be 3 waves in 360, each wave would have to be 360 divided by 3, 120. Right? So in other words, what we can say is that size of each wave, which is what we call the period, is actually 360 degrees divided by B, right? So this B is not the period, but that thing, T, is the period, because that means how big is each wave. Okay, so now what we can do is we can look at our graph and say, okay, how big is one of these waves? Well, let's go from here to here, right? So we'll start here, and we'll go down like that, up, and to here, that is 1 full wave, right? That is 1 full wave from there to there. Well, how big is that distance? Well, it's 360 degrees plus 120. It's 480 degrees, right? So in this particular case, the time period is equal to 480 degrees. So what must B be equal to? B must be equal to 360 degrees divided by 480. right? In other words, I've just rearranged this particular equation here. And if I do 360 divided by 480, I'll get 36 upon 48. Okay, 36 upon 48. And if I divide top and bottom by 12, then what I'll get is 3 upon 4, right? Which is the answer I got before. Okay, so really the key thing, guys, is you want to actually understand what these letters mean. B is not the period. That is the thing that you must really grasp and get into your head. B is the number of waves that exist in a 360-degree cycle. And so therefore it is related to the period through this equation like that. Okay? All right, so that's B. Now, what is A? A, where have I got it? Sorry, there, A. What does A refer to? A refers to the amplitude, right? Now, the amplitude is the distance from the center line up to the peak or down to the trough. So what's the amplitude going to be here? Well, what's the distance from -4 all the way up to +1? That is a distance of 5 units. And the same way, what's the distance of -4 down to -9 here at the bottom? That is also 5 units. So in other words, A must be equal to 5. Okay, guys? So that's how we analyze that kind of graph. And I hope as you go away and you practice more and more of it, you'll just be in the habit, really, of understanding how to piece that together. All right, part B. This one looks a bit more tricky. Okay, but in many ways, it's actually not as demanding as you think. The line y equals p, okay, y equals p, is a tangent to the curve, blah, 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 write down the possible values of p. Now, what's going to happen here is people see the word tangent and they think, oh, I've got to differentiate this thing and it's going to be really horrible, blah, 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 blah. But there are only 2 marks here, so it can't be that difficult. Second, what does the line y equals p represent? P is just a constant, right? So if you think about the line y equals 1, it's a straight line through 1. If you think about the line y equals 2, it's a straight line through 2. Y equals 3 is a straight line through 3. So if we just go back to this graph, and I was to draw here a straight line through y is equal to 1, right? What you should notice is that is a tangent to this curve here at that point, isn't it, right? Because that's the maximum point. In the same way, if I was to draw a line through y is equal to -9, then again, that line is a tangent to the curve at this point here and this point here, right? Because it's the minimum point. So actually, this question that you're being asked is basically saying, what are the highest points of the graph and what are the lowest points of the graph? In other words, where does the sine wave go up to and down to? So if I just go across here, and I was to think about this, right? What's the biggest value that sine can take? Well, it can either be +1 or -1, right? So sine theta or sine 6 theta, it really doesn't matter, is always between +1 as the highest value and -1 as the lowest value. Okay, well, so if that's the case, right, let's think about this. If the sine 6 theta was equal to -1, right, then y is going to be equal to 3 minus 2 times by -1. And -2 times by -1 is +2, and so 3 plus 2 is 5. Okay, and if sine 6 theta was equal to +1, then y would be equal to 3 minus 2 times by +1. And 2 times by 1 is 2, 3 minus 2 is just 1. Right, so actually, p is just equal to 1 or 5, because all it corresponds to is what's the highest and what's the lowest value of the graph. But if you really prefer, we could sketch this thing again, right? Like we did with part A. Right, part A, what does that number refer to? That refers to the center line. The center line is 3. What does -2 refer to? That refers to the amplitude, right? So the amplitude is 2 and it's kind of flipped. It's a reflection. And what does that 6 refer to? That refers to the number of waves in 360. So if I was to try to draw this out, even though it's not really necessary to do it, but if we were to try to draw it out, our center line would be at 3. So let's try to draw that on. So 1, 2, 3. Okay, so our center line is going to be at 3, like that. Okay, so here's our center line. Okay, and the graph is going to oscillate with an amplitude of 2. So it's going to go up to positive 5, isn't it? Right? Because here's 3. And it's going to go down to positive 1. So our graph is going to be like, goes up to there at its maximum point, and down to there at its lowest point. Okay, not really going to bother drawing the period, but basically the negative sign is going to look something like that, isn't it? Like that, and like that, like that. But what's the key thing for you to see? The tangent to the line is going to be here and here, right? That's the key thing. All right, so I hope you understand that. And by the way, it should also be instructive for you to just have a look at the marks, right? And just pause and say to yourself, is this question really going to need me to do all differentiation? And is it going to take me all this algebra? If you find you're spending a page of algebra for 2 marks, then you need to stop and think again and say to yourself, I think it may be there might be a simpler way. Okay, I hope that was helpful, guys. And remember, if you're liking this video, please do like and subscribe. All right, question 6 is an integration question, definite integration question. Now, it involves a reasonably popular trap. They like this particular trap, okay? Because these 2 terms here, this guy and this guy, they integrate in different ways. This guy is going to integrate to give a natural log, a ln. This guy is not, okay? So basically, that's the trap in the question. If you understand that, you should be okay. Okay, now a short little way to memorize that is basically if the power on bottom is 1, then it integrates to give ln. All right, so it's, I mean, as you do higher maths, that's not really true, but for add maths, that's basically true, and I think it's helpful. So let's rewrite this. This is going to be equal to the integral between 2 and 4 of 2 over 2x minus 3. I'm going to rewrite this as negative 3 bracket 3x minus 5 to the power of negative 2. So I'm going to rewrite it in indices form. Now I'm going to go through each term and integrate it. This guy here will become ln 2x minus 3, right? So I've got 2 times by ln 2x minus 3, but then I need to take the coefficient of the x, which is 2, and divide by 2. Okay, so that's the rule that you learn. The next term, what do? I add 1 to the power, so that'll be negative 1, and I will divide by the new power. So let's do that. So we've got negative 3, 3x minus 5. I add 1 to the power, gives me negative 1. I divide by that new power, so I divide by negative 1, and then I need to remember to take the coefficient of x, which is 3, and divide by 3, right? So just the same thing as I did with the previous term, took the coefficient of x, which was 2, divide by 2. And then I need to remember to integrate between the bounds. However, before I integrate and before I key anything into calculators, right, which is a terrible mistake. You never start keying into a calculator before simplifying. We are going to try to make all this a bit tidier, a bit neater. Okay, so 2 divided by 2 is 1. So this guy is ln 2x minus 3. Okay, now what do we got here on top? We've got a negative divided by a negative, so that's going to be a positive. We've got 3 divided by 3, so that's going to be 1. So we're going to get positive 1. And then how can I write this guy in a more helpful way? Well, we don't want indices form anymore because we've already integrated. What we actually want is to go back to a fraction. So we've got 1 over 3x minus 5. All right, so 3x minus 5 like that. And now we've got a bounds of 4 and 2. So having done that, everything is nicely simplified. Now we can substitute in our bounds. We substitute in the upper bound first. So if I do that, I'm going to substitute in 4. So ln 2 times by 4 is 8, minus 3 is going to give me 5, plus 1 over 3 times by 4 is 12, minus 5 is 7, right? So this guy is actually just 1 upon 7. Then we've got to subtract off when we substitute in the lower bound. So substitute in 2, we get 2 times by 2 is 4, minus 3 is 1, so you get there ln 1, plus 1 over 3 times by 2 is 6, minus 5 is 1, right? So we get 1 divided by 1. All right, now this can simplify further. Why? Because ln 1 is 0, because the log of any base 1 is equal to 0. The reason for that is a to the power of 0 is equal to 1, right? So if you were to convert that to log form, log base a1 must be equal to 0, okay? So that's the first thing. And then what we've got is we've got ln 5 plus a seventh, and then minus 1, well, subtracting 1 is the same thing as subtracting 7 upon 7, isn't it? And so we can simplify this to be ln 5 minus 6 upon 7. Okay, so to me, that looks like the answer in the exact form. I'm just going to very quickly check the mark scheme. Yep, ln 5 minus 6/7 is the correct answer. All right, question 7 is a trigonometric question, but it looks to me like it's going to be an identities question. So we just need to recap a little bit. Now, firstly, we've got here a cot, right? So we've got sec, cosec, and cot. It's always helpful just to recap what those guys actually mean. So cosec theta, sec theta, and cot theta. Okay, and if you want to know what those mean, you always look at the third letter, right? So 1, 2, 3, s. So cosec is 1 divided by sine. In the same way, if you look at sec theta, the third letter is c. So that's 1 divided by cos. And for cot, the third letter is t, right, like that. So cot is 1 divided by tan, right? So that's a helpful way of remembering. And then on top of that, you need to know the identities. Now, the most basic identity is sine squared plus cos squared is equal to 1. But if you divide everything through by cos squared, then sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is cosec squared, right? Because, sorry, not cosec squared, sec squared, beg your pardon, me being a bit silly. Sec squared. Because 1 divided by cos is sec, right? So 1 divided by cos squared is sec squared. And then we could also do the same thing. We could divide this guy, instead of by cos squared, we could divide it by sine squared. So sine squared divided by sine squared is 1. Cos squared divided by sine squared is going to be cot squared. And 1 divided by sine squared is going to be cosec squared. Okay, now the reason why cos squared divided by sine squared is going to give you cot squared is for the following reason. Tan theta is equal to sine divided by cos. And so therefore, 1 divided by tan theta, which is the same thing as cot theta, must be cos divided by sine, right? It's the thing flipped, basically. All right, so those kind of things you piece together. Now, of course, this identity here is given to you, actually all three of these are given to you on the front of the exam. So in a way, you don't really need to know how to derive them, but I think it's a helpful thing for you to be able to do, just so that, you know, you're more comfortable with these guys and you can flip them around and things like that. Now, in our question, we have got a cot theta, and that means I'm suspicious. I think it will be this identity here because this has got a cot. And here we've got sine theta. Well, sine is going to be very closely related to cosec, right? Because cosec is 1 divided by sine. Okay, so I think we're going to have to use that identity there. So let's rearrange a little bit. We know from the question that, let's go to yellow. Cot theta will be equal to 3x minus 2, and sine theta will be equal to root y. So that means that cosec theta, which is 1 divided by sine theta, will be equal to 1 divided by root y. Okay, so if we know those things, then we just need to substitute them into this equation here. Okay, so we are going to get 1 plus cot squared, so we're going to get 3x minus 2 all squared, is equal to cosec squared. So that will be equal to 1 upon root y all squared. Well, 1 upon root y squared is just 1 upon y, right? So 1 upon y is equal to 3x minus 2 squared plus 1. And so then if I was just to rearrange this, y is going to equal to 1 divided by 3x minus 2 all squared plus 1, right? So that's already good enough. If you want, you can expand the quadratic, but actually there's no need. That is already a sufficient answer, I think, according to the mark scheme, which I will very quickly check. Yeah, that's a totally legit answer. Okay. Okay, question 8. Solve the equation 4 sine squared 2 alpha minus 3 equals 1 for alpha is between negative pi by 2 and positive pi by 2. Now, I always find with these questions, the best thing to do is to use the substitution to make that expression there a little bit easier. So I'm going to say let u equal 2 alpha minus pi by 3. So that then the problem becomes 4 sine squared u is equal to 1, which means that sine squared u is equal to a quarter. And then we can square root both sides, so we get sine u is equal to plus or minus a half. Now that is going to be a key problem. People are going to forget the negative, right? Plus or minus. Okay, so now we're solving sine u is equal to plus or minus a half. That's a much easier problem for us to deal with. Now, what's the best way to do this? Well, you could use the unit circle, the quadrant method. I like to use a bit of variety. So in different videos, I'll use different things. In this case, what I'm going to do is I think I'm going to use the sine graph. Okay, so I'm going to draw the sine graph. You can make a rough sketch, okay? And basically, sine graph will look something like this. So that'll be pi, 2 pi, and what's this? Sorry about that. That'll be negative pi there. So the sine wave kind of goes up to positive 1 at pi by 2, comes back down like this, oh dear, through pi, then goes down to negative 1 at 3 pi by 2, and then comes back up to 0 at 2 pi. And on the other side here, we're going to go kind of down like that to negative 1, and go back up like that, like that, like that. Okay. And of course, the maximum and the minimum values of the sine graph are going to be 1 and negative 1. Now, we're trying to solve where sine u, so this graph here, by the way, just to make it clear, is sine u, isn't it, right? So y is equal to sine u. We're trying to find when this is equal to positive a half. Well, that's the same thing as finding the intersections of the sine graph with the line y is equal to a half. And then also y is equal to negative a half, right? That's the other intersection point there. So if I just do that like that. So here what we've got is we've got y is equal to a half, y is equal to negative a half. And so the intersection points are going to be this guy here, 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 right? And we want to figure out which one of these are we actually interested in, because we've got a domain of alpha is between negative pi by 2 and positive pi by 2. Now, what I suggest you do is, again, you use the substitution, because if u is equal to 2 alpha minus pi by 3, what that means is that 2 alpha is equal to u plus pi by 3, and therefore alpha is going to be equal to a half u plus pi by 6. And we can enter that into the domain here, right? So instead of writing alpha is between negative pi by 2 and positive pi by 2, we can say actually a half u plus pi by 6 is between positive and negative pi by 2, okay? And so then what I'll do is I'll subtract pi by 6 from everything. So pi by 2, right? That's the same thing as 3 pi by 6. So I'll just convert that. That's 3 pi by 6 there. Or negative 3 pi by 6. And this guy here is going to be positive 3 pi by 6. Okay, so if I subtract pi by 6 from both sides, I'm going to get minus 4 pi by 6 half u and 2 pi by 6. And then what I want to do is I want to double both sides. So this will become minus 4 pi upon 3 u and 2 pi upon 3. Okay, sorry, I just need to change that to a u because otherwise it looks like an alpha there. That's u. Okay, so basically what I want is my solutions in u now, right? So no longer solutions in a. Solutions in u need to be between negative 4 pi upon 3 and positive 2 pi upon 3, right? So if a solution for u is not within that range, then we can get rid of it. Now then, if we apply our calculator and find sine inverse a half, what we're going to get is we're going to get a sixth, or sorry, pi by 6. Okay, so that's that solution there. Well, By symmetry, we can find out that this solution here will be 5 pi by 6. Why is that? Well, because the sine graph is symmetrical about this line here, pi by 2. And what that means is that, I'll just go back, means that this point here at 0 and pi are symmetrical. And if that's the case, then that distance, pi by 6, must be the same as that distance, pi by 6 there. So if I want to find the second solution, I do pi, and then I subtract pi by 6. So that gives me 5 pi by 6. Now the thing is, right, 5 pi by 6 is already too big. It's bigger than this guy, because 2 pi by 3 is 4 pi by 6. So 5 pi by 6 is too big, so we're not interested in that solution. Okay, so then let's check out this solution here. What's that guy going to be? Well, it's the same thing as 5 pi by 6, but minus 2 pi. Now, why is that? Well, because if you think about it, what's happening is we're moving one whole wave to the left, right? So this point and this point here are identical points just on the next wave along. So if I go back 2 pi radians, I'm going to get to this guy. So what's 5 pi by 6? Let me write it down. What is 5 pi by 6 minus 2 pi? Well, it's the same thing as 5 pi by 6 minus 12 pi upon 6, which is negative 7 pi upon 6. So that guy there is negative 7 pi upon 6. Now, is that within the range that we want? Well, if we look at this, negative 4 pi upon 3 is negative 8 pi upon 3. So yes, that's the value that we want. So to recap, we want pi by 6, we want negative 7 pi upon 6. What we don't want is we don't want that value, and also we're not interested in that value either. So those guys are out. Now, again, by the law of symmetry, or actually if you just put it into a calculator, if you did sine inverse of negative a half, which is to get this point here, what you would get is you would get negative pi by 6, right? So that value there is going to be negative pi by 6. And again, using a similar argument of symmetry, this guy is going to be negative 5 pi by 6, using the same argument that we made earlier, right? In other words, this point is symmetrical with that point along this line here, which means that this distance, which is pi by 6, is equal to this distance here, right? So we go negative pi plus pi by 6, which takes us to negative 5 pi upon 6. So, in short, what have we got? We have got 4 solutions. The solutions are u is equal to negative 7 pi upon 6 and negative 5 pi upon 6 and negative pi upon 6 and then positive pi upon 6. Now these things are all solutions in terms of u, but what we want is we want solutions that are in terms of alpha. And if you remember rightly, alpha is equal to a half u plus pi by 6. So let's just write that down here. So alpha is equal to a half u plus pi by 6. Okay, well, if I half each of these values here, I'm going to get 12ths, aren't I, right? Because I half that, the denominator would become 12th. So then what I'll have to do is I have to add pi by 6. And if I add pi by 6, that's the same thing as adding 2 pi upon 12. So I'll write it like that. So let's take each of these values. Negative 7 pi upon 6 divided by 2 is negative 7 pi upon 12, plus 2 pi upon 12 is negative 5 pi upon 12. This guy will become negative 5 pi upon 12, plus 2 pi is negative 3 pi upon 12. This guy here, if I half it, will become negative pi upon 12 plus 2 pi will become positive pi upon 12. And this guy here, pi upon 6, if I half it, will become pi upon 12 plus 2 pi upon 12 will be 3 pi upon 12. So now we've got to do is just simplify these values. That will be minus 5 pi upon 12. That will be negative pi by 4. That will be pi by 12. And that will be pi by 4. And let me just check in the answers that is all correct. Yep, that looks okay to me. Hang on, wait, I just can't see it. Question 8. Yeah, that's all right. Okay, so guys, I think that's probably one of the harder questions on the paper. Basically, you get 4 marks actually for getting each of those values, right? So you get a mark for each one, and my guess is that most people are going to miss out one of the values. I think the way to guarantee you get all the values is actually to do this substitution method that I did, because then you kind of know that your values here must be between this range. Okay, so don't guess. You want to try to build up so that you know what is the range of the set of values, or rather the domain of the set of values that you are interested in. Okay, I hope that was helpful. All right, here we are in question 9. We want to solve the following set of simultaneous equations. And basically here what we need to do is we need to use the indices rules, okay? So let's just quickly recap the indices rules. If I've got a to the power of x times by a to the power of y, then I add up the indices, so it's a to the power x plus y. And if I've got a to the power of 0, that's equal to 1, right? So basically I'm going to use those rules for the first equation here, okay? So if I take the first equation, I'm going to get e to the power of x plus y, this thing, plus 3x minus 2y, right? So I'll write that out in full, x plus y plus 3x minus 2y, right? So I'm using this indices rule here. And that's going to be equal to e to the power of 0, right? Because e to the power of 0 is 1. So therefore, I get e to the power of x plus 3x, which is 4x, y minus 2y is minus y, is equal to e to the power of 0, which means that 4x minus y must be equal to 0. And that therefore means that y is equal to 4x. So that's okay. Now we just simply substitute that into here, right? So we're going to get x squared times by 4x is equal to 256. So x squared times by 4x is equal to 256. So we divide 256 by 4. So we'll get x cubed is equal to 64. And then if we cube root 64, we should get 4. Okay, and then of course we need to remember we've got to get our y coordinate as well. So y is equal to 4x, therefore y is equal to 16. Okay, so I think that's should be a fairly straightforward question. However, part B is definitely a lot more tricky. Right, so we've got to solve this particular equation here, giving our answers in the exact form. Now, this is basically a hidden quadratic, and it's very cunningly hidden. You should hopefully spot that 2x minus 1 is very similar to 1 minus 2x. Let me write it out in a way that should make it more clear. 10 e to the power of 2x minus 1 minus 11 is equal to 6 e to the power of negative 2x minus 1. Right? In other words, I can rewrite 1 minus 2x as negative 2x minus 1. That means that this guy here and this guy here are almost the same. Now, if we do this, we can use a substitution. Let's say let u equal e to the power of 2x minus 1. Okay, we'll do that. If that's the case, then here what we've got is we've got 10u minus 11 is equal to 6 divided by u, right? Because e to the power of negative, right? This thing here is like, right? So this guy here is the same thing as having 1 over e to the power of 2x minus 1. Okay, that's why the negative symbol means that. Well, if that's the case, we take this equation and we're going to multiply both sides by u. So that's going to give me 10u squared minus 11u is equal to 6. So that's 10u squared minus 11u minus 6 is equal to 0. And that is definitely a quadratic. And that's going to be a hard quadratic to factorize. And if you've got a calculator, you can use your calculator. Of course, if you don't have a calculator, you can use the quadratic formula. But I think it is actually possible to factorize with a little bit of cunning. So I'm going to try to do that for you. We want two numbers that are going to multiply together to give 10u squared. So I think 5u and 2u would be my first choice, okay, instead of 10u and 1u. And then we want two numbers that are going to multiply together to give negative 6. So one's going to be negative, one's going to be positive. And it's got to combine in such a way that we get negative 11u. Well, if I chose here negative 3 and positive 2, that's going to work. Because negative 3 times by positive 2 is negative 6. But 5u times by negative 3 is negative 15u. And then plus, this will be 4u. So negative 15 plus 4 is negative 11. So that works there. So now what have we got? we have got that u must be equal to either -2 upon 5 or u must be equal to positive 3 upon 2. Now remember, what is u equal to? U is equal to e to the power of 2x minus 1, right? So e to the power of 2x minus 1 is equal to -2/5, or e to the power of 2x minus 1 is equal to 3 upon 2. Well, if we were to natural log both sides, right, 2x minus 1 will equal to the natural log of -2/5. Well, that's not possible, right? We can't have a natural log of a negative, or another way of looking at it is it doesn't matter what x is, you're not going to get a negative here. Okay, so that guy is not possible. There are no solutions for that. But what about over on the right-hand side? Well, if I was to natural log that, I would get 2x minus 1 is equal to the natural log of 3 upon 2. And so then if I rearrange, I just add 1 to both sides. So 2x is equal to 1 plus ln 3 upon 2. And I just divide both sides by 2. So I get a half plus a half ln 3 upon 2. And that will be, I'm sorry, it's a bit messy there at the end, 3 upon 2. And that will be my final answer. Okay, so I think that is actually jolly tricky. But the key thing really is spotting that it is a quadratic in disguise. All right, question 10 is a kinematic style question. Okay, a particle P is at a fixed point O at time t is equal to 0. Now, what does that expression there mean? That means that when t is equal to 0, it's at the origin, which means s is equal to 0. So that's something worth knowing for later on. The velocity of p is given by v is equal to 3 sine 2t for t is greater than 0. I want to find the exact value of t for which the velocity is 0 for the first time after p leaves O. Okay, so we want to find when v is equal to 0, which means we're solving 0 is equal to 3 sine 2t, which means we're solving 0 is equal to sine 2t. And the thing is, a lot of students are going to do the following. They're going to do 2 is equal to the sine inverse of 0. And then what they're going to get is they're going to get 0, and they're going to say that t is equal to 0. But that's not what we want, right? Because we want to find when the velocity is 0 for the first time after it's left the origin, right? We're not talking about the origin at this point. So we want to find the next value where sine 2t is equal to 0. Well, really what you need to do is you need to have a good idea of what the graph of sine looks like. I think that's probably a helpful thing. So if I was to draw you a very fast graph of sine, okay, a sine wave looks like this, doesn't it? So like that, or like that. Like that, like that, like that, like that. Okay, and if this was just like sine x, this value here would be pi radians, and this would be 2 pi. So of course the sine wave is equal to 0 at the origin, right, at this point, but it's also equal to 0 here at pi, right? So that's what we're interested in. So we could say that 2t is equal to pi radians. Okay, and that means that t is equal to pi by 2. Okay. Of course, if you prefer, what you could do is instead of plotting the graph of sine t or sine x, you could plot sine 2t, right? And if you plotted sine 2t, hopefully you'll know that that graph would look like that instead. It's kind of compressed by a factor of 2. And so when would the velocity equal to 0 there? Would it be that point, which is pi by 2? So whichever way you choose to look at it, the key thing is you need to understand that you are not interested in the point where t is equal to 0, which is what you would get by using a calculator. Instead, what you need to do is you need to understand you're going for the next point after that. All right. Part B, find an expression in terms of t for the displacement. Well, what is displacement? Displacement is the integral of velocity, right? Now, the way to think about that is velocity is the rate of change of displacement, right? It is ds dt, right? You differentiate your displacement because velocity means the rate of change of displacement. Well, if that is true, you can reverse that to say that displacement is the integral of velocity. And so that's what we're going to do here. We're going to say that displacement is the integral of whatever our function was, 3 sine 2t. Okay, so 3 sine 2t dt. So if I integrate sine, I get negative cos. So I'm going to get negative 3 cos 2t. Then I've got to take the coefficient of the t, which is 2, and I've got to divide by that. So I get negative 3 upon 2 cos 2t, but I need to remember I've got a constant term here. Now, how do I find that constant term? Well, remember I said that this condition means that when t is 0, s is 0. So we're going to substitute that into here. When t is equal to 0, s is equal to 0. All right, so 0 is equal to negative 3 upon 2 cos 0 plus c. Now, what is cos 0 equal to? Cos 0 is equal to 1. So 0 is equal to negative 3 upon 2 plus c, which means that c is equal to 3 upon 2. So actually, our curve is going to be displacement is equal to negative 3 upon 2 cos 2t plus the c, which is 3 upon 2. Right, so that is going to be our displacement. All right, then, last question. Find the distance traveled by p between 0 and pi. Now, this is the key word here, distance, distance, distance. You need to be hyper aware of what this means. Distance is not the same thing as displacement, right? So in other words, we can't just take our s and substitute in t is pi. Why? Because there's the possibility that we have changed direction. So let's try to draw out what I mean by that. Let's say this is a measure of displacement. Okay, right. So displacement's like that, and here is our origin. All right, and let's imagine we start when t is equal to 0. So this is where t is equal to 0, and we travel forward. Okay, so we travel forward like that, like that, like that, like that. So always moving in terms of the positive displacement. And then what happens is we change direction. Now, if we change direction, we're going to go back, and so our displacement is going to decrease. Okay? So let's say we went forward 10 steps here, but went back 3 here, right? So we go forward plus 10, we minus 3. What would be our displacement? Our displacement would be 7, right? Because 7 is that distance from there to there. But if we want to get the distance would be 10 steps plus the 3, right? Because the total distance is 10 plus 3 there would be 13. So there's a difference between displacement and distance. And the key difference is whether or not you change direction. Now, how do we know if we've changed direction? Basically, we know if we've changed direction if the velocity is 0 instantaneously, right? So whenever the velocity is 0, we have changed direction. And if we go back to part A, that's exactly what we're asked to find. Find the value of t for which the velocity is 0. So this is a massive clue. That time, pi by 2, okay, is the time when the particle changes direction. Okay, so that guy there is t is equal to pi by 2. So what we need to do actually is we need to find the displacement from 0 to pi by 2, and then find the displacement when t is equal to pi. Now let's do that. So s is equal to the integral of velocity with respect to time, blah 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 blah. Okay, and if we did that, we would get, what did we get? The negative 3 upon 2 cos 2t. So negative 3 upon 2 cos 2t, and then we've got to substitute in 0 and pi by 2. Okay, and that would give us our displacement, right? So we substitute in negative 3 upon 2 cos pi, like that. Then we substitute in 0, so we get negative 3 upon 2 cos 0. Okay, now what is cos pi? Cos pi is equal to negative 1. So this is positive 3 upon 2 minus, what's cos 0? Cos 0 is positive 1. So we get plus 3 upon 2. Okay, because let's just go through that nice and slowly. If that's 1 times by negative 3 upon 2 is negative 3 upon 2. And then minus minus is plus. So we get 3 upon 2 plus 3 upon 2 is equal to 3. Okay, so that's the displacement between 0 and pi by 2. Well, what happens if we did the displacement between pi by 2 and pi? Okay, so let's do that. So s is equal to the integral of v dt between pi by 2 and pi. Okay, so let's do that, which would give us the negative 3 upon 2 cos 2t between pi upon 2 and pi. So I substitute in the upper bound, which is pi. So it gives me negative 3 upon 2 cos 2 pi, okay, minus negative 3 upon 2 cos, what was it, 2t times pi by 2 is pi, okay. And what's cos 2t? Cos 2t is positive 1. So this guy here is negative 3 upon 2 times by 1, minus, what's cos pi? Cos pi is negative 1. So we've got negative 1 times by negative 3 upon 2, which is positive 3 upon 2. So then what's this? We've got negative 3 upon 2 minus 3 upon 2, which is minus 3. So what does that number mean? It means that we've gone back by 3. So between 0 and pi by 2, we went forward by 3. And then between pi by 2 and pi, we went backwards by 3, back to the origin. So if I was to amend this diagram, basically what's happened is this, right? Like that. Okay, this is t is equal to pi. So for the first pi by 2 seconds, we go forward 3 units, right? So we go forward 3. And then for the next pi by 2, this part here, we go back by 3. So what's the total distance? The total distance is 6. Okay, distance is equal to 6 meters. Okay, now, I think that's probably quite a complicated way of looking at it, right? It's not a great way of doing it. So instead, can we think actually of a slightly better way of understanding this? Yes. And I think it's to go back and think about this displacement equation here that we found in part B. Because if you look at this guy here, we actually know, or we should know, how to plot this graph, because this is a basic sine graph. So let's try to plot it. Okay, like that, like that. Okay, now you can always go back to, I think it was question 1 or question 2, where I went through the theory of this a little bit more, if you're not totally sure what I'm doing. I want to do 3, don't I? Sorry. 1, 2, 3, 4, 5, 6, something like that. So half, 1, 2, 3, like that. Okay. Now, what does that number represent? That number represents the center line of the graph. Okay. So my center line is going to be 3 upon 2. That's going to be that line there. Okay. So the graph is going to oscillate about that point. What does this represent? This is the amplitude of the graph, but the graph is also flipped, right? Because that's the negative. So the amplitude is 3 upon 2. So I'm going to go up by 3 upon 2. So 3 upon 2 plus 3 upon 2 is going to take me all the way up to 3. So I would go up to there. All right. Oh, it's not great. Never mind. And I would go down by 3 upon 2 to here, back down to 0. Then lastly, what does this 2 represent? This represents the number of waves in 2 pi radians. So if I've got 2 waves in 2 pi, then it means the size of one wave is going to be pi radians. Okay, so the period is going to be pi radians. Okay, let me just try to do that. So 2, 3, 4. So that's going to be pi. That's going to be pi by 2. So this is a negative cos graph. So it's going to come down from here. What do it look like? It will look like that. It's going to look like that. It's going to go up to the top here. Oh dear, it's not very good. It's going to go down to the bottom there. Oh dear. Sorry guys, not so easy to draw. Okay, like that. Okay, so what does this mean? It means that for the first pi by 2 seconds, I go up to a displacement of 3. And then for the next pi by 2 seconds, I go down from 3 back down to 0, right? So I start with the displacement of 0, I move up to 3, and I go back down to 0. So actually, what's my total distance? My total distance will be equal to 3 plus 3, which is 6, right? Which is the same answer as I get through integration. So personally, if you ask me, I actually think knowing what the graph looks like is a much better way of doing this, right? But the important thing is you should be able to understand actually all the ways of doing it so that you're really well equipped when it comes to the exam to do a question like this. Okay, I hope that was helpful, guys. Don't forget to like and subscribe. All right then, question 11. The tangent to the curve y equals 3x minus 1 to the power of a third at the point where x is equal to 3 meets the coordinate axis at the points A and B. And the points with coordinates AA lies on the perpendicular bisector of AB. Find the exact value of A. Okay, now look, you notice that this is what? It's 3 sentences long, but it's worth 10 marks. So it's very dense, this problem, and a lot of you are going to get quite intimidated by it. With any big problem, the way you handle it is you break it down into smaller, more manageable parts. So let's try to do that. We have got the tangent to this curve at the point where x is equal to 3 meets the axes at the points A and B, right? So A and B is going to be the x and y intercept of the tangent. So what do we need to find first? We need to find the tangent line. Okay, if we want to find the tangent line, don't we need 2 things? The first thing we need is we need a coordinate point on our line. And the second thing we need is we need the gradient of the line. If we've got those 2 things, we can find the equation of any line that we want. So, how do we get the coordinate point? We are going to have to substitute x is equal to 3 into the curve. So let's do that. When x is equal to 3, y is going to equal to 3 times by 3, which is 9, minus 1, which is 8. So we're going to get 8 to the power of a third. And the power of the third is the same thing as the cube root, okay? And the cube root of 8 is 2. So the coordinate point is the point 3, 2. So we've already got that. How do we get the gradient? Well, we get the gradient by differentiating the curve, right? So let's do that. Y prime, right? I've got to do a chain rule here. So I'm going to take the power, which is a third, bring it down to the front. So I got a third, 3x minus 1. I've got to subtract 1 from the power. So a third minus 1 is minus 2/3. And then I've got to differentiate inside the bracket. So if I differentiate 3x minus 1, I get 3. So I multiply through by 3. And of course, the third and the 3 cancel off. So what I'm left with is 3x minus 1 to the power of negative 2/3. Now I'm interested in the gradient when x is 3. So when x is equal to 3, y prime, the gradient, is going to equal to 3 times by 3, which is 9, minus 1, which is 8, to the power of negative 2/3. Now what does that power mean? Well, the negative means we've got 1 over, 1 divided by, we've got a reciprocal. The denominator means we've got the cube root, right? So this is the cube root of 8. And what does the numerator of the fraction mean? Well, we raise it to that power of 2. Okay, so the negative is 1 divided by, the denominator 3 means we're cube rooting, and the power of 2 on the numerator means we're squaring. So what's the cube root of 8? The cube root of 8 is 2. 2 squared is 4, so we've got a gradient here of a quarter. So let us recap. Our gradient, m, of the tangent is a quarter. And what is our coordinate point? Our coordinate point is 3, 2. 3, 2. So how do we get the equation of the tangent? Equation of the tangent, we do y minus y1 is equal to m x minus x1, x minus 3. Okay, and notice, by the way, how I'm always explaining what's going on, and I'm writing it in a nice, clear way, right? M is equal to this. I write the point. I explain that I'm finding the equation of the tangent. You want to make it super clear to the examiner that you know what you're doing. I'm just going to rearrange this a tiny bit just to make things a little bit easier. So I'm going to multiply both sides by 4, and then I'll write whatever. 4y is equal to x plus 5, I think. I think it's probably quite a nice way of writing that. And remember, what I now need to find is, I want to find where this meets the coordinate axes, right? I want to know the x and the y intercepts, because that's going to be my point A and B. Okay, so the x-intercept is where y is equal to 0, right? Because the y coordinate's always 0 on the x-axis. So if y is equal to 0, we get 0 is equal to x plus 5. And what does that mean? That means that x is equal to negative 5. Okay, that's that. The y-intercept is when x is equal to 0 for the same reason. On the y-axis, the x-coordinate is always 0. So if we do that, 4y is going to equal to 0 plus 5. So therefore, y will equal to 5 divided by 4. So let's try to write this now as our 2 coordinates. Let's say the coordinate A is the point negative 5, 0. And the coordinate B is the coordinate 0, comma, 5 upon 4. So now we've got those 2 points there. So we've already done that part of the question. Let's go up and read the rest of the question. So we've got these points A and B. The point with coordinates AA lies on the perpendicular bisector of AB. So it's probably going to be a good thing to find the perpendicular bisector of AB. Right, so let's now try to do that. What does perpendicular bisector mean? It means the line that is perpendicular to AB and that goes through the middle of AB, right? So it goes through the midpoint of AB. So let's come down here. I think I'll draw it out so you get a reasonable idea. Let's try to draw some axes. Okay. Okay, so if I was to draw that, 1, 2, 3, 4, 5, that's -5, right? So that would be the coordinate of A there. And B is 5 upon 4, so it's 1.25. So let's say that's 1, that's 2. B is going to be roughly there, isn't it, right? Where that value is 5 upon 4. So that guy's B. So what do we mean when we say the perpendicular bisector? Well, the line AB does that, doesn't it? And so the perpendicular bisector is going to go through the midpoint and it's going to be perpendicular. So it's going to look something like that. Okay, that's the green line there. Runs perpendicular to AB and goes through the midpoint of AB. So it goes through there, the midpoint. So if we want to find the equation of the green line, what do we need? Well, it's the same as before. We need two things to find the equation of any line. We need a point on the line and we need the gradient of the line. So the point on the line is going to be the point M. So how do I get the midpoint? Well, the formula for the midpoint is I add up the two x coordinates. So I do -5 plus 0 and divide by 2. So that'll be -5.2. And I add up the two y coordinates. So 0 plus 5.4. And I divide by 2, which will be 5.8. So I get that. That is the midpoint. Next, how do I get the gradient of this green line? Well, if I find the gradient of the blue line, if I find the gradient of AB, I can use the negative reciprocal to find the gradient perpendicular. So the gradient of AB, so M subscript AB, so I'm nice and clear, is going to be y2 minus y1, so 5 upon 4 minus 0, over x2 minus x1, which is 0 minus minus 5, right? So minus minus 5. So if I do all of that, that gradient is 5 upon 4 divided by +5, which is 1/4. Okay, so I've got that gradient there is 1/4. In fact, I think I knew that before, didn't I? Because I already calculated the equation of the tangent, so that's sort of unnecessary. Do forgive me. Anyway, never mind. And then what do we know about the gradient perpendicular? The gradient perpendicular is equal to -1 divided by the gradient of the tangent. So -1 divided by 1/4 is -4. So we have got the point of the green line. We've got the gradient of the green line. So we can do y minus y1 is equal to mx minus x1. So let me just do that. So we are going to get y. So I'll write here. Equation of perpendicular bisector. Okay. Y minus y1. So y minus 5 upon 8 is equal to m -4 x minus x1. So x minus 5.2. So x plus 5.2. Okay, now that's actually already good enough, right? That is already the equation of the perpendicular bisector. And we know that the point AA lies on this line. So what we can do is we can just substitute x is A and y is A into here. So we get A minus 5/8 is equal to -4 A plus 5 upon 2. All right, well, let's try to simplify all this. I'm going to times everything through by 8, I think. So that will be 8A minus 5 is equal to -32A. Oh, sorry, -32 bracket A plus 5 upon 2. So on the right-hand side, that's negative 32a. Okay, 32 divided by 2 is 16. And then 16 times by 5 is going to be 80. So that's negative 80 there. So equal to 8a minus 5. And I will add 32a to both sides. So that'll be 40a. And I will add 5 to both sides. So that will give me negative 75. And then I need to divide both sides through by 40. So I'm going to get negative 75 over 40. I suspect that divides by 5, doesn't it? So 75 divided by 5, I think, is 15. 40 divided by 5 is 8. And so I think the answer for A is negative 15 upon 8. Now, I'm just going to double check that against the back. Negative 15 upon 8 is indeed the correct answer. Okay, so I hope this was helpful. And what I really want you to see is the way to do this problem is you are breaking it down. And you're doing each individual part nice and patiently and carefully. That's the way to do this kind of thing. All right, I hope this video was helpful. If you liked it, please do like the video, share it, and subscribe. Take care. Bye-bye. Okay, so here we are in question 12. It is given that y is equal to ln 3x upon x squared for x is greater than 0. We want to find dy dx. We want to differentiate this function and give our answer in this form here, where a and b are integers. Okay, well, here we've got one function divided by another function, which means we need to use the quotient rule. So we're going to call the thing on the top u, so that's ln 3x, and the thing on the bottom v, so that's x squared. And hopefully you'll remember that the quotient rule is v du, so v times by u prime, minus u dv, so u times by v prime, all over v squared, right? So what we need to do is we need to calculate an expression for u prime and v prime. Well, if I differentiate ln 3x, the 3x goes on the denominator, and I differentiate it to get 3, and I put that on the numerator. Well, of course, 3 divided by 3x is the same thing as 1 upon x. So I'll just write that as 1 upon x. If I differentiate v to get v prime, then x squared becomes 2x. So now really what I've got to do is just got to substitute this in to the formula for the quotient rule. So v is x squared, u prime is 1 upon x, minus u, which is ln 3x. And I'm just going to stick that in a bracket like that, times by v prime, which is 2x. And I deliberately put those in brackets because I want to avoid the mistake of thinking I've got ln 3x times by 2x, which is ln 6x squared, right? That's wrong. That's not right. I can't take that 2x and multiply it into here, okay? And the reason for that is the 3x is actually inside of the function ln, all right? Okay, on the bottom, what have I got? I've got v squared, which is x squared squared, and x squared squared is going to give us x to the power of 4. All right, so let's tidy everything up. Firstly, x squared divided by x is just equal to x. And this can be rewritten as negative 2x times by ln 3x. And we're dividing it all through by x to the power of 4. And if that's the case, then we can divide top and bottom by x, right? So in other words, we cancel that one off. That just leaves us with 1. Cancel that one off. And that would become x to the power of 3. So if I was to now rewrite that, I've got 1 minus 2 ln 3x, all divided through by x to the power of 3. And I believe that's in the form that we're asked in the question yet. So a would be 1, b would be negative 2. Okay, so that's our answer there. Okay, then, part B, hence, we want to find this integral here. Now, the key word here is the word hence. Hence means we've got to use our answer from part A. So let's try to think about that. In part A, what we did is we showed that this thing here, ln 3x divided by x squared, differentiates to give this thing here. So if this differentiates to give that, then what that means is if we were to integrate this thing, then we would go back to ln 3x upon x squared. Why is that? Well, because integration is the reverse of differentiation. Okay, so if I take this guy here, 1 minus 2 ln 3x. So let's write that down like that over here. So 1 minus 2 ln 3x, all divided through by x cubed. Right? If I was to integrate that, then what I would get is I would get the function that I had at the very beginning, right? Ln 3x upon x squared, right? This thing here, okay? So I would get ln 3x upon x squared. And then plus c, because we've always got to add the constant. So this is really the key thing, guys. What you want to do, I would always encourage you to rewrite the part A as an integral, right? So you've differentiated this to get that, which means that if you were to integrate this, you would get back to that. Okay, so if you write out this statement here, you should really get one method mark because you've demonstrated that you understand that integration is the reverse of differentiation. Okay, with that understood, we now need to try to isolate this particular integral here. So how are we going to do that? On the left-hand side, I can split apart this integral. This is the same thing as the integral of 1 upon x to the power of 3 minus 2 ln 3x upon x to the power of 3 dx. Okay, and is it equal to that thing on the right-hand side? Now you can see that this guy is pretty close to the integral that we want. So what I'm going to do is I'm going to split apart this integral now into two parts, 1 upon x to the 3 dx, and then minus 2 lots of the integral of ln 3x upon x cubed dx. So can you see that? What I've done is I've taken this integral here, and I've split it up into two separate integrals, right? The integral of that and the integral of that. And I've also been able to take out the -2 outside of the integral sign. Why is that helpful? Well, because it leaves me with the thing that I'm trying to find, the integral of ln 3x upon x cubed. Okay? So now basically I've just got to calculate everything else. So this term here is the integral of x to the power of -3 dx minus 2 times by the integral that I want, so ln 3x upon x cubed dx, and that's equal to the ln 3x upon x squared plus c, okay? Ln 3x upon x squared plus c, all right? So if I integrate x to the power of -3, I get x to the power of -2 because I add 1 to the power, and I divide by the new power, so I divide by -2. Minus 2, the integral ln 3x upon x cubed dx, and equal to the ln 3x upon x squared plus c. Okay, so now what I'm going to do is I'm just going to rearrange so that I can get this guy here on its own. And in order to do that, I'll imagine I kind of move this to the right-hand side. Okay, so if I move it to the right-hand side, I will get plus 2, the integral of ln 3x upon x cubed dx. Okay, I'm going to move this guy here to the left-hand side. So I'm going to get -1 upon 2 x to the power of -2 minus ln 3x upon x squared. And I can bring the c to the left-hand side as well, but c is just a constant, so I don't really need to write it as -c. I can write it as positive c, because remember, we don't actually care what the constant is. We just care that there is a constant. Okay, so now once you've done that, basically the only thing we've got left is we've got to divide this whole thing through by 2. So on the left-hand side, I'll get -1/4 x to the power of -2, which is the same thing as 1 upon x squared, minus ln 3x upon 2x squared. Yeah, and plus c, again, divide by 2 doesn't really matter. And so that will be equal to the integral of ln 3x upon x cubed dx, right? So we've actually found out our answer there. This is the thing that we're asked to find. Okay, so I'm just going to check the mark scheme to see that I'm all right about that. Okay, so just give me 1 second just to find that. Yep, absolutely right. Negative 1 upon 4x squared minus ln 3x upon 2x squared plus c. Okay, so that is the answer. And the key thing, guys, is I think you want to try to understand where that is coming from. And where it's coming from is you are reversing the differentiation from part A. Okay.